Hello. So now we're starting chapter 3, polynomial and rational functions. And we're going to start with quadratic functions. I know that we talked about them a little bit, but we're going to actually go deeper into what a quadratic function is now. So the standard form of a quadratic function is f of x equals a times x minus h inside parentheses squared plus k. A cannot equal 0. So this is in vertex form. The graph of f, I'm sorry, I feel a sneeze coming. Let's see if it comes or not. Okay, the graph of f is I pressed something, um, parabola, whose vertex is the point hk. So if we kind of sketch it here, I'm gonna do an x-axis and a y-axis here. And then I'm just gonna go ahead and sketch some sort of a parabola. Now for this one, hk would be the vertex somewhere here. So h is the x-coordinate and k is the y-coordinate of the vertex. Okay, the parabola is symmetric with respect to the line x equals h. So we could draw a line. So if this was an exact graphing, this line x equals h, if we had a paper and folded it along this line x equals h, both sides of the parabola would go on top of each other. Now, of course, I kind of sketched it, so it's not as symmetric. But when you're graphing it accurately, it should be symmetric along that line. Now, if a is greater than 0, the parabola opens upward, as we can see over here. This is when a is greater than 0. Now, if a is less than 0, it opens downward. And it looks like this. Now, our vertex would be here. Well, actually, the axis of symmetry looks like it is, I drew it the same, so it would be x equals h. And then a is less than 0 right here. Okay, so let's look at the steps for graphing quadratic functions with equations in vertex form. So again, we have it in the vertex form. So first, we're going to determine whether the parabola opens upward or downward. So if a is greater than 0, it opens upward. If a is less than 0, it opens downward. That's an a. So again, this number here tells us what it is, if it opens up or down. Second step is to determine the vertex of the parabola. The vertex is hk. So here and here. Now notice with h, this is a negative. So you have to think kind of the opposite of what we're seeing. And we'll look at an example in a little bit. Okay, step number 3 is find any x-intercepts by solving f of x equals 0. The function's real zeros are the x-intercepts. Step number 5, find the y-intercept by computing x equals 0 or f of 0. Same thing. Step number 5 is plot the intercepts, the vertex, and additional points as necessary, and then connect these points with a smooth curve that it is shaped like a bowl or an inverted bowl. Okay, let's look at an example here. So we are graphing this quadratic function right here, and remember that the vertex form is f of x equals a x minus h squared plus k. So first we need to determine how it opens. Looking at our a here, we only have a negative sign. Well, that means that it is actually a -1. We don't write the 1. It is kind of, well, someone used the term understood one. So if there's not a number, it is a 1. -1 is less than 0, so it does open downward. So it's going to look something like this. Now, next we need to find the vertex. The vertex is HK. Actually, you know what? Let me use another color here. HK, and H is this right here. Oops. And K is this number right here. Now, again, remember that the form is x minus h. So the minus sign is there. So that is why our h is going to be 1 and our k is going to be 4. So h is 1 and k is 4. So h is a positive 1. If it was a -1, the sign in between would be a plus because it is a minus. Okay, so our vertex would be right here, 1, 4. That's just a sketch. We're actually gonna go ahead and graph it down here. Okay, step number 3. We are finding x-intercepts by solving f of x equals 0. So we're gonna take our f of x, negative parentheses open, x minus 1 parentheses close squared plus 4 equals 0. And now solve for 0. We are moving the -4, or solve for x, I'm sorry, not for 0, solving for x. Negative x minus 1 squared equals -4. Now remember this negative here is the same thing as -1. So we're going to divide both sides by -1. Those cancel each other out, and we get x minus 1 squared equals a positive 4. Now we're going to take a square root, positive and negative. X minus 1 equals positive and -2. So we have x minus 1 equals -2 or x minus 1 equals positive 2. And then we add 1, we get -1, or when we add 1, we get x equals 3. So our x-intercepts are going to be 3, 0, and -1, 0. Next, we're going to find the y-intercept by computing f of 0. So we're going to plug in 0 where we have x. So negative 0 minus 1 squared plus 4. And we're going to do this calculation right here. So -1 squared is a 1 plus 4. -1 plus 4 is 3. So our y-intercept is going to be 0, 3. Okay, now with the points that we've got, we're able to graph it and everything that we know. So we're going to start with our vertex, 1, 4. So our vertex is going to be 1, 1, 2, 3, 4 right here. That is 1, 4. Next, we're going to go ahead and graph the x-intercepts, which are 3, 0, and negative 1, 0. So 1, 2, 3, 0 is right here, and negative 1, 0 is right here. Then we're going to graph that y-intercept, so 0, 3, 1, 2, 3 right here, 0, 3. And now we know that it opens downward, so we can just go ahead and go through these. And again, it's not, like you can tell that I don't have a point here, which kind of makes it a little bit harder. Let me make a correction here. 1, negative 1, 0 is right here. What I can do, even though I don't have a point on the right side to make it a little bit easier, remember that this is symmetric along the vertex right here. So since this point here is 0, 3, our y-intercept is here, there needs to be a point right across from it um, with the same length from the axis of symmetry. So there is a point 2, 3. And if you're not sure, we can do the calculation. I mean, we're missing that x equals 2, so we can just plug it in here. Negative 1 minus 1 squared plus 4. Yeah, sorry, it was a 2, not a 1. That's 2 minus 1. That's what I was looking at. So this is instead of Rx. So negative 1 squared plus 4. 1 squared is 1. The negative is outside of it. So we're going to have a negative 1 plus 4, and that equals a 3. So our point is 2, 3. So that's how we calculate it. Like I said, we can also go with the axis of symmetry, which is x equals 1, and just graph it, or yeah, graph it through that. Okay, now hopefully it is a little bit easier to graph an actual, there we go, an inverted bowl. Okay, now we're going to go ahead and look at an equation that looks like this. F of x equals ax squared plus bx plus c. And this one here is the standard form that we're looking at. So if we have the parabola defined by the quadratic function f of x equals ax squared plus bx plus c, the vertex is going to be negative b divided by 2a, that's the x coordinate. And then once we have that x coordinate, we can plug that in to find the y coordinate. And again, we're going to look at an example how to do it. So the x coordinate is b over negative b over 2a, and the y coordinate is found by substituting the x coordinate into the parabola's equation and evaluating the function at this value of x. So f of negative b over 2a, that would be our y. Okay, so when we are graphing these functions that are in the standard form, f of x equals ax squared plus bx plus c, we're first going to determine whether it opens upward or downward. So again, the same thing. If a is greater than 0, it opens upward. If a is less than 0, it opens downward. Next, we're going to determine the vertex of the parabola. So the vertex, again, the x coordinate is negative b divided by 2a, and the y coordinate is going to be f of, when we plug in the x coordinate, so negative b over 2a. Third step is find any x-intercepts by solving f of x equals 0. So the real solutions of ax squared plus bx plus c equals 0 are the x-intercepts. Step number 4, find the y-intercept by computing f of 0. because f of 0 equals c, the constant term in the function's equation, the y-intercept is c, and the parabola passes through c0. And then step number 5, plot the intercepts, the vertex, and additional points as necessary. Connect these points with a smooth curve. Okay, so let's look at graphing with the standard form here. So we're first going to determine how does it open. There's our function. So what we want to do is we want to look at our remember, this is ax squared plus bx plus c. So our a is going to be -1. Again, there's only the negative sign, but there is a 1 because it doesn't have a number. B is going to be 4, and c is going to be 1. So if we look at these here, our a is -1, which means that it is less than 0. So that means that it opens downward. So sketching it looks like this. Next, we're going to find the vertex. So our x-coordinate of the vertex is going to be -b over 2a. Negative b equals 4, so 4 divided by 2 times a is -1. Now, we have two negatives here that become a positive. 4 divided by 2 is going to be 2. So this is our x-coordinate. Now, what we're going to do is when we're calculating the y-coordinate, we are plugging this in to our function. So f of 2. So we're going to take our function, -x squared, instead of the x, we're writing 2 squared plus 4 times 2 plus 1. And again, notice that this negative sign here is outside of the x squared. So it is going to be -4 plus 4 times 2 is 8 plus 1. So our y-coordinate is 5. So our vertex for this is going to be 2, 5. So the 2 is the x-coordinate and 5 is the y-coordinate. Okay, next we're going to calculate the x-intercepts by solving f of x equals 0. So -x squared plus 4x plus 1 equals 0. Now, looking at this, we're not going to be able to factor this. So what we're going to do is we're going to use the quadratic formula. So x equals -b plus minus b squared minus 4ac, square root of all this divided by 2a. We already listed our a, b, and c over here, right here. So we're just going to go ahead and plug those in. So we get x equals, hold on a second, -4 plus minus square root 4 squared minus 4 times a, which is -1, c is 1, divided by 2 times -1. Okay, so everything inside the square root plus minus 4 squared is 16, and we get plus 4. Under 2 times -1 is a -2. X equals -4 plus minus square root of 20 divided by -2. Now, what we can do is 20 can be written with a perfect square, 4 times 5. So we can, when we do square root of 4, that's going to be a 2. So negative 4 plus minus 2 square root of 5 divided by negative 2. We're going to divide by 2. Negative 4 divided by 2 is negative 2. Plus minus 2 divided by 2 is a 1, square root of 5. And now what we need is we still have a negative 1 under here. So negative 2 divided by negative 1 is going to be a positive 2, and the positive and negative stay because it doesn't matter which way it is. So 2 positive and negative square root of 5. I'm just checking because my key has a different answer here. But yes, we've got a, yeah, negative 4. Yes. So 2 plus minus square root of 5. Okay, let me do this now. I'm going to have to kind of go backwards to make sure that I've got enough room. So this is the accurate, but now what we can do is we can actually go ahead and plug these two in a calculator to just see where we are. So negative 4 plus square root of 20 divided by negative 2. If we plug this in the calculator, we get negative 2. We get negative 0.2. So it's 0.236. And if we plug in the negative square root of 20, we get 4.2. So when we are sketching, these would be our x coordinates for the x-intercept. So it would be negative 0.20 and 4.20. We're not, so we need to now round them as a decimal because we're not able to sketch 2 plus square root of 5. That's not something that we can do. Okay, next, find y-intercept by computing f of 0. So we're going to plug in 0. So negative 0 squared plus 4 times 0 plus 1. So we get a 1. Just like it said that our y-intercept is going to be the constant c here, which we just did. Okay, now we're going to start plugging in the points. Our vertex is 2, 5. So we're going to go ahead and plug that in here. 1, 2, 1, 2, 3, 4, 5, right here. 2.5. And then we're going to plug in the x-intercept, so negative 0.20. And this is we're doing decimals, so it's going to be an estimate somewhere here. 4.2, 1, 2, 3, 4.20 is going to be right here. About. Zero, 1, so our y-intercept is going to be right here. Okay, so we're going to go ahead and it opens downward, so we're going to kind of sketch it like this. There we go. We really can't graph. I mean, yes, we can graph additional points, but it is going to be more of a sketch anyways, since we're drawing it with kind of free hands. Okay, next, we still need to identify the function's domain and range. So we're going to look at our graph here. So the domain if we look at the domain, it keeps going all the way, even though it doesn't go fast, but it will. There's no restrictions on the where it goes on the x-axis. So it is all real numbers, or we can write it negative infinity to infinity. Range, on the other hand, it starts from negative infinity. It goes up to where the vertex is. The y-coordinate of the vertex is 5, so that is going to be our range. And 5 is included. Negative infinity is always with a with a parentheses. With and hold on, 5 is a bracket because it is included. Okay, next what we're going to look at are the minimum and maximum of quadratic functions. So consider, again, the standard form, ax squared plus bx plus c. If a is greater than 0, then if the function has a minimum that occurs at x equals negative b over 2a. This minimum value is f of negative b over 2a. So that is, okay, let me sketch this. Let me just, I'm going to go ahead and do there we go. And now if I sketch this, a opens upward like this. So our minimum right here, again, it is at x equals, so whatever the vertex, x coordinate of the vertex is, that is where it is at, and the value is the um, y coordinate of the vertex. Okay, now if it opens, or if a is less than 0, it opens downward, right? So it looks like this. Then f has a maximum that occurs at x equals negative b over 2a. So again, that is where, that is the x coordinate, is where the maximum occurs at. So this maximum value is f of negative b over 2a. In each case, the value of x gives the location of the minimum or maximum value. The value of y, or f of negative b over 2a, gives that minimum or maximum value. Okay, so let's go ahead and look at an example here. So we've got f of x equals 4x squared minus 16x plus 1000. So first we're going to determine, without graphing, whether the function has a minimum or a maximum value. So the very first thing that I like to do is write our a, b, and c. So again, this is f of x equals ax squared plus bx plus c. So a is 4, b is negative 16, and c is 1000. Now our a here, so determine without graphing whether the function has a minimum or a maximum. Our a is 4, which is greater than 0, so it has a minimum because it opens upward. So it looks something like this. So the minimum is right here. The vertex is the lowest point. Okay, let's look at the next one. Find the minimum or maximum value and determine where it occurs. So the location for it is going to be x equals negative b over 2a. So negative 16 over 2 times 4. Negative and negative become a positive, so we get 16. 2 times 4 is 8, so this is 8. So minimum value occurs at x equals 2. Next, we need to calculate the value. So we're going to go ahead and plug this 2 in to our function. So f of 2 equals 4 times 2 squared minus 16 times 2 plus 1,000. 2 squared is 4, so 4 times 4 minus 16 times 2 is 32 plus 1,000. Now you can plug this in the calculator and do it all at once. Um, 16 minus 32 plus 1,000 is going to be 984. So this is the minimum value for this function. Also, we know that the vertex is going to be at, so 984 is the y coordinate and x is 2. So this is the vertex. But at the same time, minimum value occurs at x equals 2, and the minimum value is 984. Okay, what else do we need? We need the domain and the range. So our domain, just like all quadratic functions, it is going to be all real numbers. Range, we have a minimum now. So it starts from whatever the minimum value is, which in this case is 984, and it goes all the way up to infinity. And 984, the minimum value is included. The infinity is written with the parentheses. Okay, so strategies for solving problems involving maximizing or minimizing quadratic functions. So make sure that you read the problem carefully, just like any problem. This means that we're going to be looking at a word problem. And decide which quantity is to be maximized or minimized. Use the conditions of the problem to express the quantity as a function in one variable. Rewrite the function in the form f of x equals ax squared plus bx plus c, so the standard form. Calculate negative b over 2a. If a is greater than 0, f has a minimum at x equals negative b over 2a. This minimum value is going to be f of negative b over 2a. If a is less than 0, f has a maximum at x equals negative b over 2a, and this maximum value is going to be f of negative b over 2a. And then answer the question posed in the problem. Okay, so let's go ahead and there's an example right here. I'm not sure why the example is actually, or the title is on this page. So you have 120 feet of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? So decide what must be maximized or minimized. Well, it's asking us to maximize it. So we are maximizing. Now, if we think about the question, it is asking find the dimensions of the rectangle that maximize the enclosed area. So what our goal is to maximize the area. We don't know the dimensions yet. Okay, we have a rectangle right here, rectangular region. Now, if we think about calculating the area of a rectangle, that is length times width, right? So we're going to set one of these to be x and one of them to be y. So area is x times y. Now, what we do know here is that there's 120 feet of fencing. So this whole thing, if we go walk around it, is 120 feet. And so what we need to figure out is um, the perimeter. So 2x plus 2y, so there's two x's and two y's when we walk around it. If you're not sure, you can just go x plus x plus y, kind of like walk around this whole thing. Equals 120. That's how we calculate the perimeter. Now what we want to do here is we want to solve for the y in this one. So we're going to go ahead and move the x to the other side with the 120. So we have 2y equals 120 minus, actually, let me do it right here under. So 2y equals 120 minus 2x. So I just subtracted the 2x. Now I'm going to divide by 2 so I can isolate the y. So I get y equals 60 minus x. Next, what I'm going to do is I'm going to take the area here. Area is x times y. I'm going to plug this 60 minus x where the y is, like this. So I get a equals 60x minus x squared when I distribute the x. So this will be our function. We have one variable x. That's why we had to get rid of the y here and plug this number, 60 minus x, this expression in there. Now, next we need to write the function in the form f of x equals ax squared plus bx plus c. So all we need to do is write a of x equals and bring the x squared first. So just switching the order. So now our a is going to be -1, b is going to be 60, and c is going to be 0. There is no constant here. So next step for us is to calculate x equals -b over 2a. So x equals negative, b is 60, 2 times a is -1. Again, we have two negatives. Those cancel each other out. 60 divided by 2 is 30. So x equals 30 is where the maximum occurs at. Okay, now we need to answer the question posed by the problem. So what was the actual question here? What is the maximum area? So we need to calculate the maximum area. So our function was a of x equals -x squared plus 60x. Now we calculated that x equals 30 is where the maximum occurs. So what we're going to do is we're going to go ahead and plug that 30 in where we have the x. So a of 30 equals -30 squared plus 60 times 30. Plug that in the calculator and we get 900. So the maximum area is 900 square feet. And that is our answer. Okay, that's it for this lesson. Let me know if you've got any questions. Bye.